So we are talking about the methods of solving linear equation, among which I have discussed it could be solved by direct method or it could be solved by iterative or indirect method. So in the iterative part we have already discussed the Jacobi method. In today's class we will be discussing the Gauss-Seidel method. These two topics or two methods will be discussed for your course, and I think these two are enough for your course. So in today's class we will be discussing the Gauss-Seidel method, but before discussing Gauss-Seidel method, it's a kind of similar to the Jacobi method. There are some modification in the Jacobi methods which we are will be observing in the Gauss-Seidel method. So before going to the Gauss-Seidel method, let me recap the Jacobi method for you, okay, with one example. So let's say this screen is visible to everyone.
Yes, sir.
Okay. So I have given you this example before that I asked you to solve this one. So to solve this one, what I told you, you have to arrange or rearrange these equations in such a way that it has the diagonally dominant condition. One condition you will be considering for Jacobi method, that is your diagonally dominant. So you will be looking after the diagonally dominant conditions, okay, and after seeing the diagonally dominant condition, how you can get the diagonally dominant condition. So if you arrange these equations like this way, before writing any matrix or before doing anything, so I will suggest you to write or rearrange this equation in diagonally dominant conditions, where you are just flipping the positions, or you are just interchanging the position of equation 2. This equation goes here, and this equation you can see goes here. By doing so, you will have a diagonally dominant positions. Only consider the mod part, so we will be not considering the sign. So here 8, 7, 9, this is the diagonally dominant conditions, like this you are achieving, okay. Now after doing that, what you will do, you will from this equation you will be calculating x1, from this equation, from the second equation, this one, you will be calculating x2, and from the third equation you will be calculating x3, like this. Now in this condition, in the Jacobi method, what we do, for r plus 1th iteration, that's the condition, right? At the outcome of r plus 1th iteration, what we are having, x r plus 1, that's the output value, or that's the outcome, or that's the result. You will have the x2, so always put a first bracket, the iteration point, then x3 r, okay. So at r plus 1th iteration, like at second iteration, you will be putting the value of the first iteration, or you will be putting the results from the first iteration. Here you will be for same goes for x2 r plus 1 r, x3 r, then x3, for the x3 r plus 1, 12 x2 r. So here we will be considering a initial guess. So considering or having these equations, we will be solving this equation like this way. We will be making a table, then we will be write the 0 iteration. 0th iteration means I am considering the initial guess. At the initial guess condition, you are considering most convenient one, that x1 equals to 0, x2 equals to 0, x3 equals to 0, okay. Now I'll be putting this value for the first iteration. This is our first iteration. So if I put this value here, x1 value, like the x2 value here, and x3 value from here, you will have the result of x1 equals to 1. Now if you put that value in the second equation, you will get the value of x2 at first iteration. At first iteration you will get the x3 value from considering this condition. So you got the result, or you got the outcome after first iteration. So after second iteration you will be having this result by putting these values. By putting this result you will be having these values. So what we are doing here exactly? In this condition, in this Jacobi method case, we will be first calculating all the variables value x1, x2, x3 in this case. So x1, x2, x3 values will be calculated for a particular iteration. Then we will be putting that value for the next iteration, or that will be our input values for the next iteration. In the Gauss-Seidel method, we generally don't do that. We generally modify that portion. So here you can see, what you can see, that the let's consider this x2 value. Okay. Okay, now let's consider this x2 value, and this x2 value, you can see that x2 value is consisted, or is coming out from the values, or the here the what are the input values here? X1 and x3. X1 and x3 is the input value for x2. Now in this iteration you can see that x1 value got updated. It's got updated, right? So the x1 value you got initially that 1 for the, but x3 value you know 0, because you didn't calculate the x3 value. So to calculate this value for the Gauss-Seidel, remember I am talking about the Gauss-Seidel. So to calculate this value you will be putting this updated value. So in case of Gauss-Seidel method, what we are doing, we are basically putting the latest value in the equation, or the updated value in the equation. The latest value of x1 you got, it could be from that iteration, or it could be from the previous iteration, doesn't matter. The updated or the latest value you are getting, that will be your or that value would be put or that will be your input value for the result of x1 or x2, or whenever you are calculating x3. Got it? Now for the Gauss-Seidel method, let's solve the following problem. Write this down, solve the following problem. So I'll explain the Gauss-Seidel method with this problem. Okay, up to Gauss-Seidel method, is it clear to everyone? The concept is clear, what we are trying to do? Sagnik?
Yes, sir. Yes, sir.
It's clear, right? Okay. And you have the result from the previous class, that what if we didn't consider the diagonally dominant condition, so what would be the result? Your result wouldn't be converging, because you are getting 10, 12 these kind of values in place of 0.571 you are getting 12, or you are getting 11 like this, or you in place of 1.095 you are getting some large values. So your problem will not be converging if you are not considering the diagonally dominant condition. So that's the one criteria for the Jacobi method. Another criteria for the Jacobi method is that Jacobi and the Gauss-Seidel method. This diagonally dominant condition is also applicable for the Gauss-Seidel method, because you have to find out the diagonally dominant condition. You have to rearrange your equations. That's the trick here. The trick is to rearrange your equation in such a way that it becomes diagonally dominant. We got the idea, right? And this diagonally dominant condition, and for the Gauss-Seidel method we will be putting the updated value. Jacobi method is more like a more like a easiest consideration. There is no confusion there. You will be calculating for the first iteration, then you will go for the second iteration. Here you will be putting the updated value, whatever the updated value. If you got the updated value of x1 in the second iteration, and if it's required in that iteration, then you will be putting that x2 value. That's the simple difference between Gauss-Seidel method and the Jacobi method. And one another criteria it should you should consider that for the Gauss-Seidel and the Jacobi method, the diagonally dominant condition you have to consider. One more thing, that the coefficient of, like here, x1, x2 and x3, the coefficient of the diagonally dominant condition or diagonally dominant variable shouldn't be 0. Okay, so in this case, if you are rearranging like this, your x1 shouldn't be multiplied with 0, then you cannot get a result. You cannot do the Gauss-Seidel method. Okay, so to solve this problem, you can see it's a 2x1 minus x2 equals to 7, then minus x1 plus 2x2 minus x3 equals to 1, then minus x2 plus 2x3 equals to 1. So it can be written as 2x1. I'm writing this way. So write this down, 2x1 minus x2 plus, I'm multiplying with 0, I'm considering with 0 multiplied with x3. So that it's for my own convenience, so that I can understand what's actually happening and how the matrix is formed. What is the A matrix here? X equals to B, you remember, Ax equals to B. So here A matrix will be 2, minus 1, 0, minus 1, 2, minus 1, 0, minus 1, 2. So for my own convenience, and for one thing that I do not do any mistake in the exam, so I preferred and I suggest you to write in this way. Is it clear to everyone? Now for the Gauss-Seidel method, and I hope you remember the style 1, style 2. Are you done with this writing up to this?
Yes, sir.
Okay. Yes, sir. Now for the style 1, how I told you, style 1 for the people who are not confident in a tabulation format. So what they will do, they will first either it's for style 1 or it's for style 2, you have to first calculate the x1 value. So you will be calculating the x1, like rewrite x1 value, you are getting half of 7 plus x2. Okay, x2 value you will be getting half of how much? What is the value? 1 plus x1 plus x3. Okay, now x3 value you will be getting half of 1 plus x2. And one more thing, see here, this thing is already diagonally dominant condition. So 2 to 2 is there, so the coefficient of x1 is greater than, so here the coefficient of x1, so it's x1 plus bx2, I am writing an equation, plus c x3 equals to, let's say, d. If a greater than b plus c, okay, then you will go for this method. So you have to look after that which one is the more dominant one, which coefficient is the largest one, and you have to arrange in this way. So this requires practice. You have to practice a lot, then you get the idea. So x1 I can write half of 7 plus x2. x2 I can write half of 1 plus x1 plus x3. x3 I can write half of 1 plus x2. These values I got. Now I'll be discussing for the style 1. See, this style 1, style 2 is of my own understanding. There is no thing like style 1. So I'm presenting this problem, or I'm presenting the solution of this problem in two style. This is style 1 in the in the extended version. Style 2 would be your tabulation version. Okay, so what would be the initial approximation here, class? Initial approximation, what we are considering?
0th iteration.
Okay, it's a 0th iteration, so I'll be writing x1 0 equals to 0. Similarly with x2 0 equals to 0, and x3 at 0th iteration equals to 0. So you can do one thing here, you can put 0 here. So x1 0, x2 at 0th iteration, x3 at 0th iteration equals to 0. Now I'll be calculating the x1 value. Before calculating the x1 value, I'll be writing that for the first iteration, okay, x1 1 would be half of 7 plus x2 0. What is the latest value of x2? That is our 0. So what value I am getting? 3.5, right? Okay.
Yes, sir.
Okay. Now x2 1, what I will be doing? Half of the 1. First let me write x1 plus x3. Okay. So x1 value I got. So here remember the Jacobi method. So in Jacobi method we used to write it says first is the initial approximation x1 at 0th iteration, but here as I have this result x1 at first iteration and I am doing the first iteration, still I am in the first iteration step, but as I have the updated value here, what I will do, I will not be doing the 0 1, I will be putting the value of x at first iteration, and x3 value, the updated value we have the 0. Now find me the result. What would be the result here? What would be the, it's a 2.25. Got it? Now you have to tell me what will be the value of x3. So let me first write x3 equals to half 1 plus x2. So what would be the value of x2 here? Which iteration? x2? Shagnik?
First iteration.
X for the first iteration. Okay. Then it will coming around.
1.1.
Are you sure?
No, sir. 1.17.
625.
No.
So 1.625.
Yes. It's coming around 1.625. So these are the result from your first iteration. Okay. Now I will be doing the second iteration, and I have to consider and I have to remember the time, because I'm not allowed to get extra time on for this. So either if you are going for the style 1, then you have to be you have to do the calculation very fast way, or you have to be you have to be very fast about your calculation, and you have to be write in a very fast way. So your handwriting speed should be good enough to complete all this writing. Now for the second iteration, I will not write these equations again. If you are not confident enough, do write that. But then again, I don't expect that you will get extra time for that. So it's a 5 marks question. Hardly you will have 4 minutes to complete it. Okay. So for the second iteration, x1 2 half of, just you'll be seeing this equation. Okay, And after seeing this equation, so you will be seeing this equation, and after seeing this equation, try to write by your own. Like it will be 7 plus the latest x2 value I know is 2.25, so I'll be writing 2.25. Is it okay for everyone? So it will be around 4.625. For the again for the second iteration, x22 half of 1 plus x1 is consisted of two values, or the right hand side has two values of x1 and x2 x3, so you will be putting the values of x1 and x3, the latest value. So x1 value will be how much? X1 value is 4.625, sorry, x1 value is 3.5, x1 value is 3.5, and this value will be sorry, the latest value of x1 would be 4.625, so that will be I'll be putting that here, 4.625 plus again I'll be putting 1.625. The result, tell me the result. So it's coming around 3.625. Okay, now for x3 as second iteration, half of it's only required the latest x2 value. Latest x2 value is 3.625. okay, so it's coming around 2.3125. okay, now for the third iteration, you have to do it and tell me what will be the result after third iteration. So I am writing here x1 third, what would be the result? I am writing here x2 third, what would be the result? I am writing here x3 at third iteration, what would be the result? Do it. So what is the value after third iteration? x1, x 5.3125. okay, and x2 4.3125, and x3 2.65625. Great. Okay, so that's coming from the iteration number third, and so on. You'll be able to calculate the fourth, fifth, and sixth or seventh. So it will be converging around seventh iteration. Okay, so and the result will be x1 equals to so the result will be x1 equals to 5.9570. After 7th iteration you will get the result. x2 equals to 4.9570, and x3 will be around 2.97 0.85. Okay, so this would be your result, or you can you may this is optional. Okay, so this could be your answer. You can write this is our answer, or you may write that the answer is 6, answer is 5 and 3. I am approximating this. Now put this value in any equation and let me know if you are getting the result or not. Let's put the value for the in the first equation. So first equation, if you put the value of in the first equation, you will have 2 into 6 minus 5. So 12 minus 5 equals to 7, and other side you can see it's coming around 7. Got this?
Yes, sir.
Okay. So if you want, you may approximate it. Otherwise, these are your result. How you will get the result? Anyone from last concept or from the Jacobi method? So when the results will be repeating or not changing, that will be your final result in this case. Okay, so that goes the style 1. Now let me talk about the style 2. Okay, now I'll talk about style 2. And style 2, I generally prefer to go with the style 2, and I will suggest you to go for style 2. Okay, so what is style 2? It's the same thing you are doing, but here I'll be representing my result in a tabular format. How I'll be representing? I know the value of x1 at r plus 1th iteration, x1 value would be half of 7 plus x r. Okay, now x2 value would be at r plus 1th iteration, half of 1 plus x1 r plus 1 plus x3 r. Now x3 value, this is more convenient in my opinion, that you will be seeing these equations and you will be putting the value. So half 1 plus x2 r plus 1. Why r plus 1? Because you have the updated value of x2 at r plus 1 iteration. That value will be putting that value here. So I'll make a table. Okay, so in this side I'll be writing iteration. This is x1, x2 and x3. Initial guess is 0 0 0 0. Then I have the value 1 at first iteration. What is the value? What are the values of x1, x2, x3? 3.5, 2.25, and third one is we did calculate 1.625. Now at the second iteration we'll have 4.625, 3.625 and 2.3125. Okay, now for the third iteration, what is the value of x1? Is coming around 5.3125. What is the value of x2? It's coming around 4.3125. What is the value of x3? It's coming around 2.65625. Okay, so these are the values in 3 iterations. For the third iteration, this is the value. Okay, so this is for the second iteration, this is for the third iteration. Now find me the value of fourth iteration and calculate the value of fourth iteration and just let me know. So this is the iteration, this is x1, iteration x1, x2, x3. Now for the fourth iteration, what will be the value of x1? What will be the value of x1?
5.6565
5.65625.
65625.
x2
4.65625.
4.65625. x3 2.828125. Okay, and so on. So your homework would be, what would be your homework? Your homework would be do this iteration and up to 7, 6 and 7. So you have to do 3 steps more. So do it now, do it in the classroom, then you will see the result. Up to 7th iteration, do it and let me know the result. What will be the result in the fifth iteration? Then in the 6th, then in 7th. What would be the value? Everyone, Devani, are you getting the same value? Are you getting? Yes. Okay then. So tell me the values for 5th iteration, x1 value.
8 point.
So this is actually x2. Okay. What is the value at 5th iteration? Okay. Eight point 82 5.82 8125. Is it Sagnik?
Yes.
X2 4.828125. Okay, see, your results are converging. It's almost reaching to 6. Okay, the variations or the changing in the values are not that much higher. Okay, so if you plot it in a graph or anything else, so for the numerical modeling, what we do, we generally plot it with the graph. Suppose this is the result. Suppose this is the result. Suppose this curve, for some reason I am taking a parameter p with respect to another parameter p2 with respect to x, another parameter. So this is our field data. What we do, we generally take several models, several idea. Like I take the initial assumptions 0 0 0, means I am considering some values. Similarly, I'll be considering some values, and I'll be getting a result, a outcome, and that outcome you will be plotting with the field data. And if you are plotting this with the field data, then you will be seeing follow this. So initially it might be showing like this. So this is your result after first iteration, which was or which is not near to this your true value. So there is error. Then you will be updating the model, and you will be having in the after second iteration like this. Generally this modeling cases, these things are not happening in the second or third iteration. It takes several lot of iterations, like 1000 iterations. Now in the third iteration, what will happen? Let's say the red line is for the third iteration, and it's near to the values, like this way. See, this is the way it's converging. And now tell me the value of x3, Sagnik.
These are 2.91.
2.9140. 2.9140. 625. Okay. Now sixth iteration.
X1 is
5.9140. 625. Okay. So if it's not convenient for you, you might take up to 4 decimal point, means up to 406. It's very difficult to get the result by using calculator up to so much decimal point. But if you are not having enough time to think about that, go ahead with this. Okay, means you have a chance to approximate if you are comfortable one. If you not, I'm happy with that. Okay, now for the sixth iteration, for the x2 value, you'll be having just you have to add x1 and x3. Last x1 I am getting this one, and x3 I am getting this one, so I'll be getting 5.9140 and 2.91, and it's coming around plus 1 4.9140. Okay, that's the value of x2. Now value of x3, 2.9570. So the result is coming around 2.9570. Okay, to the seventh iteration. So you can do the 1000 iteration with this also. Yes.
So for x1, 5.95703.
Seventh iteration.
So for x1, 5.9
Is it for the 7th iteration or 6th iteration?
Yes, sir. Seven, seven,
plus
sir.
7.
Yes. So is coming around. Who is talking?
So Priyash,
Priyasmita. Okay. 5.95.
703.
703. Okay. Then your x2 value
4.95717.
95717. Okay. And
X3 2.97858.
2.97858 na?
85. Yes.
Okay. Again you can do the iteration and you will be having C. Initially the jump or the difference between the data. So our objective, so initially you have this much of deviation. Initially you are having this much of deviation. This much of deviation you are having initially. Then is the deviations or the differences between the true data and the model data decreases. Then you are having almost near to the values. Now if you approximate these values, you will have the result like x1 value 6, x2 value 5 and x3 value 3. Or you may write this would be your answer. So I will specify do it up to 7th iteration. And don't think it will not go or it will not find the result. So eventually it will be becoming more final near to the 6 value. So it will be becoming like 5.98 something. It will be then 5.99 something. It will be then 5.9903, let's say. Then it will be becoming 5.9905. Then it will be becoming 5.9907. So we can do up to, let's say, 1000 iterations. Then it will converge. But for the sake of simplicity and for today's class, for the class purpose or for your numerical problem with your own hand, for this purpose this will be your final result. So you'll be writing the results are, or you'll be writing answers. I would like to see, or so what I prefer, that whenever you are writing answer, you will write the answer. So I asked what would be the value of, what would be the solution, then you will be writing x1 equals to this value, x2 equals to this value, x3 equals to this value, and then you will be writing answer, so that I can understand that okay, this is the final answer. So this style 2 is more convenient because you will be using the tabulation part, not much of writing you have to do. Okay, so this is how you will be doing the Gauss-Seidel method. Now this problem, as far my knowledge, I didn't do by the Jacobi method. So to do so, let's solve that problem, the previous problem. Let me show you. Solve this problem with your with Gauss-Seidel method. Solve this problem with Gauss-Seidel method. So these values you are getting, just make this tabulation, write this down quickly from here to here, then here, then here. So these are you have already written for the Jacobi method. So you may write these values as for this class. Just write these values and then calculate these values for Gauss-Seidel method. So what will happen for the Gauss-Seidel method here? Sorry. So what will be the values here for the Gauss-Seidel method? I'm not talking about Jacobi now. I'm talking about the Gauss-Seidel method. Let me take the screenshot here. Okay. Gosh. So what will happen in the Gauss-Seidel method in this condition? So here what I'll do, let me erase this portion also. I am r plus 1 x1 r plus 1 x3 value, you don't know the r plus 1, so it will be r. x2 value you know, x2 value we know the r plus 1. Give me a minute, okay. These things are very inconvenient. Okay, so x2 value it will be r plus 1, and what will be the x1 value? It will be also r plus 1. R plus 1, and this will be also r plus 1. Got it? To view. So for the Jacobi method we are considering these values r, but here as we have the r plus 1 values, so we will be putting the r plus 1. Now from here we will be making a table iteration, and we will be having the value x1, x2 and x3, and then you will be saying what are the pros and cons of Gauss-Seidel method, why we should apply or why we should consider the Gauss-Seidel method over Jacobi method, and how fast it's converging. So do that, and you have the previous day's result. I don't have, you have the result I think, and compare today's result, today's from Gauss-Seidel method results with that previous Jacobi result, and tell me. So initial approximation 0 0 0. First, what will be the result? x1 value plus, hello,
1.
it will be 1. Then x2, this 1 value will be
0.7142.
so 5 by 7, it will be 5 by 7, right?
Yes, sir.
What is the value is coming?
0.7142.
0.7142. For x3,
1.0317.
1.0317. Okay. Similarly for 2, similarly for 3, and you will be seeing it's converging earlier than the Jacobi method. Actually Jacobi method was not reaching properly, we terminated our iterations at some point, but Jacobi method was not reaching to that point. But Gauss-Seidel method can reach easily after 2 or 3rd iteration or 4th iteration, I don't know. So you know the Jacobi result. If I do this by Excel, so I have the iteration number, and then I have the value of x1, I have the value of x2, and I have the value of x3. Okay, 0, 1. So x1 value 0, 0, 0. In this case, the x1 value would be okay, the x1 value would be 1 minus 0.125 star this value plus 0.125 star this value x1. x2 value would be 0.571 plus 0.143 star this one, okay, plus 0.286 star this one, okay. x3 value will be equals to 1.333 minus 0.222, and now we have the value of x1, okay, so it will be the updated value minus 0.111 star x2 value this one. Is it coming to everyone? So this value you are getting, Sagnik, Priyashmita?
Yes, sir.
Okay, so assuming these values are right, and now so see, these values are coming around 1, okay, so 8 plus 1 minus 108, yes. So these values you can see, if you consider up to second or third decimal point, then you can see that these values from 5th, 6th, or it's starting from 1, okay, or better it's starting from here. After second iteration, you can see the values is giving is near to 1, and here it converges up to 1. So I can go up to few iteration, and you can see this is giving you the 1 result at 8. And put the value in first equation. What will be the result? Or in the second equation. If you don't believe me, then put the value in the second equation also. You will see the result of x1, x2 and x3 is 1, 1, 1. But in your examination, you won't get time. Right? So I'll specify the do it up to 5th iteration and find me the result. So if you approximate from here, from the second iteration, you will have the result 1, 1, 1. Am I right?
Yes.
Okay, so and for the Jacobi method, at which iteration you are getting the result? At which iteration? 6, 7 iteration you are having the result, but here you can have the result at second iteration, or to be specific at third iteration. So after seeing the third iteration, you can see that the values are not changing much, so it will be your result. You will be approximate it, or you might do the approximation part. So this is the basically advantage of doing Gauss-Seidel method. if you couldn't see it. So if you want to write this, let me do one thing, let me have this screenshot and I'll send it to your WhatsApp. Okay, but you should check these values by calculating manually. Okay, so I'll send it to you. So by doing so, you will have the Gauss-Seidel result, and you can, so far we have discussed the Jacobi method and Gauss-Seidel method. I'll give you some problems to do at your home and do that. Okay, and if you have any questions, just ask me.